My name is Mohammed Tariq, and in this lecture, I will try to deliver the in-order traversal using iterative method line by line. I will try my best to walk you through the code, and I will explain the coding flow, that how it works. On my right hand side, I have a PowerPoint slide with a tree already ready for your help. And on my left hand side, I have the NetBeans IDE in which I'll code. And with that, with coding, I will also try to explain you how it's actually going to work. So let's start the implementation. So we already have discussed the recursive flow, the in order recursive flow, and in this lecture, our focus is in order traversal using iterative method. So let's implement public void and let's say in order iterative, in order iterative, and we can take the root node here and we can take the root node here also. Let's check. Let's first make a check if root if root is equals to null, and if the root is null, we need not to go any further. We can return from here, right? Uh, okay. We have the void method, so we need not to do any return. Now let's take a stack. As we know, we need a stack, and we will make it the node generics, and we need a stack, and let's name it stack. And okay, now let's write the node and name it current. Okay, let's name it current and assign the root node. And we can also, what we can do is we can also pass the root from here in this method as a parameter. Okay, we can do that also, but I am just taking the reference of the root to the current. Okay, now what we will do, we will first try to iterate over it. If you understand, if you remember our last code, so what we did is we uh, pushed all the left side nodes into the stack. So if you see this, all these nodes, we will push all these left hand side nodes into the stack and then we will iterate it. So let's try. Uh, I'll write some comments also. So what I'll do first, node to be visited will be the left one. Okay, and now I will loop current is not equals to null. It will keep on looping until we get a null value. Okay, and then we'll say stack dot push. Let's push them, and whatever is in the current, let's push that into the stack, right? And then we will say current is equals to current dot left. Now let's traverse. Now it's time to traverse, and we need to check the right hand side also. Now let's traverse the tree. Okay, now we will also take help from a loop, and we will say stack dot size. We will check its size. If its size is greater than 0, it means if it's not null, the stack is, and stack has elements in it. So what we will do is we will pop the element from the stack. Okay, we will pop the element from the stack. So we'll say stack dot pop whatever is the element is. So at this point, we have all the left hand values or the left nodes already in the stack, and then we'll pop the first value and we will check that does it has a right node also or not. So we'll pop the value and then we will print. Okay, we will print here. We will print the value. We will print. whatever is in the current node, current dot data, current dot data, and then uh, it's a we adding a space, and now we will check if current dot write. Now we need to check the write node also. Current dot write. If that's not equals to null, if that's not equals to null, then what we would do, we, would, we will do node equals to current equals to current equals to current dot write. So we are assigning whatever is in the right hand side of the node to the current. So if you are not getting this flow, so don't worry. I'll debug this code for you, and with the help of this tree that I have at the right hand side, we will see how this code is flowing. Okay. Now, if we have, let's say if we have for example this node, this 30. When we will reach this 30, we need to also check that does it has a node at the right hand side, and yes, it has. So if it has a right hand side node, we need to assign this to the current node, and then we will make further decisions. Now we have a current node. Now we will check if this current node has a left hand side node also. For example, if this node, this 45, it can have a left node here, a left reference here, a left hand side tree, a left subtree here, right? So we need to check this also. So here we will check this while current, whatever is in the current, if it's not equals to null, if it's not equals to null, then what you would do is stack. If it has a let's suppose if we have a right, for example here, let's say if we have something here. So if we have a node here, something like this, and then we have a node here, something like this, and then we have a node here, something like this, right? This can happen. This can possibly be the case, right? So we need to take care of this. If this right has a left node or not. If it has a left node, then we need to see if it again has a left and right nodes or not. So this we also need to take care of. So coming back to the code, so we need to check stack. We will push whatever it is. We will push that into the stack. We will push whatever is in the current, and then we will say current is equals to current dot left. So we'll keep on pushing whatever is in the left node. For example, if we have a left node here, for suppose if we have we raise this one, and let's say for example this one, we have a left node here, again we have a left node here, again we have a left node here, again we have a left, right? This can happen. Let's say here we have one right side. So we need to take care on the right hand side. So this is the right hand side for 20. Okay, this is a right node for the 20. And this right node has a list of and has a set of left hand side nodes. So what we are doing is exactly this line. This line is exactly what it's doing. It's this loop is again adding all the left nodes. And here is the semicolon. So now this method is now complete, and let's make a debug pointer, and let's erase all these writings, and now let's try to understand this. And what we need to do, I need to call this. So I'll first, what I'm doing is, let's comment this, and I'll say bst dot in order iterative. Okay, and now I'm calling the in order iterative method debug. Okay, so this tree is already there. Okay, you can see these elements. These elements have been inserted. So based on these elements, we are going to debug this method. Now concentrate on the green uh, pointer. I'll walk you through the code, and I'll also take the help from this right hand side PowerPoint to make this clear. Okay, root is not null. Okay, now we have Now the pointer is here. We give it a stack, right? It's the stack now has been created, and the root is now pointing to the current. So now the root is pointing to the current. Now what I can say here, so the root, so this is current. So the current is now pointing to the root. Now the current is at the root, and push the stack, the push whatever is in the current into the stack. So let's draw a stack here. Let's draw a stack here. Let me draw a stack. We draw a stack. Let's say here we have a stack, and what we are pushing 50, right? We are pushing now current dot left. So now the left is here. The left, you can see the left is 30, and now we are uh, making reference to the left. So now the pointer is here pointing to this one, and it's no more pointing to 50. Okay. Now again, current is not null. Now push whatever is in the current reference into the stack, and then make the reference of the left to the current. So now pushing the current element, which is 30, into the stack, and then the left of the 30 is 20, is now going to point here, and this will no longer be pointing here. Going to the same way. Okay, now we're gonna push what we're gonna push 20 here, and then pointer will gonna point in this side, and we have this. So now what we have is, okay, now we'll again check if the current is equals to null. It's not null because it's pointing to 10. We will push 10. We will push 10 here. So we'll push 10, and now it will check the left. Now I think it will show null. Yes, you can see here we have null, current is equals to null in the tooltip. So now we have inserted all the left elements, right? All the left hand side nodes into the stack. And now we can start the checking of the root and the right hand side. So here in the code it says stack size is greater than 0. Stack size is greater than 0. The next line is to pop. We are popping stack.pop into the current. Whatever is in the stack, let's give the reference up to the current. So now the current is actually pointing to the 10. Okay, actually it's pointing to 10, and we will print the value of the current. So the value of the current we have, uh, the value of the current is actually 20. Will print, sorry, is 10. We will print 10. So we will print here. We will print 10. Now we'll check if the current has the right node. The current does not have the right node. As you can see, it's null. It's null on the right hand side. So it's went back to the stack. Now the stack size is not empty, and we have popped this, so we will remove this from here. Okay. Okay. Now we will pop what is the next element is 20. So, and we are giving reference to the whatever is in the stack. We are giving it to this current. So now current pointer, the current reference is actually pointing to 20 now. Okay. We will pop this out, and then we will print. So we are gonna print, 20, and we have popped this out. Now we will check if it has a right reference, current dot right. So it is current, and this is the right, and it has a right reference, which is 22. Now let's see how the code works. Now it came in because this condition becomes true, and current dot right, we are giving the reference of the right hand side node to the current. So whatever is in the right, we get giving the reference to current, and we are removing this from here. Now we'll check if current is not equal to null. Yes, it's not equal to null because it's referencing to 20. Now we need to check if it has a right hand side reference, right? If this 22, this node has a sorry, this 22 has a left hand side reference, right? So first we're gonna push this. We're gonna push this into the stack. So here we're gonna push this into the stack, which is 22, and then we'll check for the left reference, left current dot left, but current dot left is null. So we'll check if current is null. Yes, it is null because there is no reference, as you can see in the tooltip also. So it's going back, it's going to the loop again, to the while. Now, what it says stack dot pop. What is in the stack is the latest element is 22. We're gonna pop this out and then we're gonna print this. Okay, so here it says print and check its right node because we have already checked the left reference which it does not contain. We also need to check its right reference. Okay, so let's first print here what 22, and this has also been popped out. Now let's check the right node. It does not have a right node. It's going back. So now it's saying stack.pop, and what we have in the stack. Now next is 30. So in the stack we have 30. So it's gonna point. So this gonna pointer is gonna point to 30. Okay, and then we're gonna print this also, right? We will print. We will print 30. We will print here 30, and this will be again be popped out. Okay, then we're gonna check its right. It has a right node, as you can see. It has a right node connected, which is 45. 45 current dot right. Now the current is pointing to 45. Current is pointing to 45. Okay. Now we're gonna see if it's not equals to null. Yes, it's not equals to null. Then we have to push it. We'll first push that 45 into the stack. Let's push that into the stack. Let's push 45 into the stack and check for its left side. Right? We'll check for its left side. And if there is no left node associated, so it would be a null, and then it went back. So as you can see here, I have covered this part. I have covered this part, this section. Okay, this one. And as you can see, the working of the iterative traversal, how we use the stack, and how the code is actually flowing, and how we are printing the values using the in order traversal method. So in this way, you can print the complete tree. So I hope this will be helpful for you, and I want you to understand this flow by yourself. And I would then again strongly recommend you to write the iterative methods for pre-order traversal and for post-order traversal. That will make you that will give you confidence that you can write the code on your own. I hope this will be helpful, and I'll see you in next lecture. Thank you.